Hey guys, welcome back to the Chapter 8 practice test here for statistics. In this video, we're going to look at questions 12 and 13. 13 promises to be pretty long. So let's get started without delay. Number 12 says that we have a 95% confidence interval for the mean reading achievement for a population of third grade students. And we got 44.2 to 54.2. If you remember that was from an earlier question too. Suppose we compute a 99% confidence interval using the same information. Would that new interval be narrower or wider? The confidence interval gives a list or a set of plausible values for any given parameter. So the confidence interval gives us plausible values for the parameter. And when we consider it that way, then it seems to make sense that if we want to be more confident, we need to have more plausible values for that parameter. And then, of course, more plausible values, then that means that we have a wider interval, more possible values for whatever that parameter is going to be. So we would expect a interval that's, somewhere smaller than 14.2 to 44.2 to somewhere larger than 54.2 if we went to the 99% confidence interval. And finally, since we have more plausible values, then that should mean that there's less of a risk of being incorrect. So really, the way of looking at confidence intervals using this vocabulary of plausible values really solves a lot of the problems that a lot of students have interpreting confidence. We're going to move on to this next question where we have the U.S. Forest Service considering additional restrictions to the number of vehicles allowed to enter Yellowstone National Park. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Of those 150, 89 say yes. So that's all the information we need to construct and interpret a 99% confidence interval. So construct and interpret, that right there, that means four-step plan. So getting ourselves set up, we've got state, plan, do, and conclude. We see, of course, 89 out of 150. They're basically asking a yes and no question. So for a yes and no question, you're not measuring anything, you're just taking a poll. So this is a proportion. So we've got P is the true proportion of visitors that favor additional restrictions. Remember, try to pull pieces from the problem into your statement here of the parameter. Our confidence level is 99%, and that takes care of the state part. Now we got a plan. So the name of this procedure is just going to be a Z interval for P. I like to put two things in here, or three things really, but right now we're only going to worry about two of them. We like to put the name of the curve we're going to use, the Z curve, because we're dealing with proportions, and of course the parameter that we're going to be estimating, so a Z interval for P. Now remember, we have three conditions: random, the 10% condition, and the normal condition. Now remember, normal doesn't mean normal like in we always do it, normal as in the normal curve. So let's start with random. Do we have anything in the text that says we have a random sample? Ah, I see it right there. A random sample of 150 visitors. That takes care of our first condition. Next condition is a 10% condition. So we start with a sample size, and that needs to be less than 10% of the population. So in this case, less than 10% of all visitors. And then we say that this is likely, seems likely at least, because there needs to be more than 10 times the sample size. So 1,500 visitors to Yellowstone National Park. Finally, we have this normal condition, and for proportions, the normal condition is always going to be large counts. NP is just the number of successes. You don't have to worry too much about that. It's just 89. Of course, that's greater than 10. course, we should be using p hat here, but okay, so n times p hat is 89 greater than 10. N times 1 minus p hat, that's just going to be equal to 61. Remember that np or np hat and whatever number we put here, that needs to add up to the sample size. So 89 plus 61, that should be equal to 150. And of course 61 is greater than 10. So the normal condition, condition number 3, the normal condition, that is passed as well. So we're all set. We're ready to do our confidence interval. Let's get to the do part. Here we're looking for the general formula, the specific formula, substitution, and then an answer. The general formula is the same for every confidence interval. It is a point estimate plus or minus the margin of error. Specific formula, you got p hat plus or minus z star times the square root of p hat 1 minus p hat over n. Ooh, that's a lot of things to memorize now, isn't it? The only thing we need to substitute here is z star and p hat. So p hat is 89 out of 150, of course. Z star for the 99% confidence interval. Most people have memorized that at 2.576. Check even just the previous video, and we talk about solving for that z star. And p hat, over here we've got 89 and 61 out of 150. The whole thing out of 150, and that's all the numbers substituted. You might be asking, can I put a decimal in there for p hat? Sure, no problem. After doing all the arithmetic, you get yourself 0.5933 plus or minus 0.1033. That's a pretty big margin of error, but it makes sense because, like we said in the previous problem, large confidence level, that means a big interval. Big interval, that means a large margin of error. So we're ready to conclude here. We are 99% confident that the interval from 0.4900, 0.6966 to 0.6966 captures the true, and we're going to come up here. There's my phrase. So the true proportion of visitors that favor additional restrictions. Adjust for readability. We are 99% confident that the interval from 0.4900 to 0.6966 captures the true proportion of visitors that favor additional restrictions. Sounds great. Okay, everyone, that is our video for this time. We'll see you next time when we tackle the last two problems on this practice test. Have a good one.